Lesson 11. 3D CAD modeling with Tinkercad, and 3D printing. Contents. The topics covered in this lesson are 3D CAD modeling, VEX EDR clawbot CAD. The task or activity for this lesson includes Tinkercad setup, configuration, 3D CAD modeling. 3D CAD modeling. 3D CAD, or three-dimensional computer-aided design, is a technology used for designing components in various industries. Some of the industries mainly include manufacturing, architecture, medicine, entertainment, and more. Creating 3D CAD models. There are three main types of 3D modeling. Let's talk about solid modeling. It generally works with three-dimensional shapes like cubes, spheres and prisms. They act as the building blocks for the design. Wireframe modeling. It is used when the surface is complex and curved. It represents shapes as a network of a minimum 3 vertices or polygons. A 3D mesh is the structural build of a 3D model consisting of polygons. As a note, all models are exported to meshes before printing. Surface modeling. This is used in complex designs, with freedom to shape the model's geometry, according to designers' requirements. Some of the popular CAD softwares include AutoCAD, SolidWorks, Fusion 360, 123D Design, Tinkercad, Blender, Rhino, and ZBrush. This video explains how to model a mag wheel in AutoCAD software. Expressive humanoid robot with 3D printed parts. This robot was made by the parts printed at Makerspace, NYU. VEX clawbot CAD. The parts of the VEX clawbot used for this curriculum are as shown in the figure. It has been modeled in Autodesk Inventor, a software for design and assembly of 3D parts. All parts, namely, bearings, gears and other similar components, can easily be reproduced, using the software. These parts are ideal for the process of 3D printing. Here are also the parts printed by injection molding process of the VEX clawbot. If you want to learn the modeling and design of the VEX clawbot, follow the links which give clear instructions to do so. This video tutorial teaches you how to design VEX clawbot in a software called GrabCAD. Tinkercad. It is a free website to create 3D design, electronic circuit design and coding. Why should we use 3D printing in STEM? 3D design platform. We have free, web-based, Tinkercad software, for designing. Math. We can implement the use of measurement and geometry in the design, to analyze surface area, and volume, of composite shapes. Science. To incorporate science in design, and testing, such as, of a race car, to study motion, and building of bridges, to study modeling and scaling, and more. Start using Tinkercad. Go to tinkercad.com in a browser. Use Google Chrome or Firefox, recommended. Remember, when using Safari, you must enable WebGL. Click on Sign up for a free account. Click on Personal account. Sign up with email or sign in with Google or Apple. Follow the steps on the screen to create your own design. Click on Create New Design. Select from different design options. We can see many options to create different shaped parts. Choose basic shapes as an example. Drag and drop any shape you wish to use. Edit your project name, on the top corner as shown on the screen. You can keep adding any designs you like to create your new project. If you want to edit your existing project, you can do so, by selecting your project by the corresponding name, as shown on the screen. All your projects will be visible on your homepage, under My Recent Designs. Once you click on the project you have two options. Click on Tinker this to edit your project. If you want to download your project, click on Download and get ready for printing it. Getting ready for 3D printing. Make sure to check your file format, which must be STL or OBJ extension. Also, while designing the project, make sure you do not have these features. They increase the complexity and might ruin the print of the model. You can study more on these issues to learn how to proceed in case you come across any in your designs. For now, let us have a brief introduction to these concepts. Overhangs. They are geometric shapes in a 3D models that extend outward, so they don't have a direct support while printing. Loose face. The parts need support while printing. If support is not provided, the structure can hang and not hold shape. Inverted normal. It is the normal axis or face of the design that is pointing in the wrong direction, telling the computer that an outside face is actually an inside face when it isn't. Intersecting geometry. It happens when the edges of the shapes intersect. You can find many free designs to download from the following websites. Let us see a few examples of 3D robot parts. This is a robot chassis, or the base where the wheels are mounted on the bottom, and all the parts of a robot on the top. This is the model of the mount for an ultrasonic sensor. We have here a robot wheel model. We can see many models of things you may use in your daily life like keychains here. We also have the logo of NYU. A few more examples. Activity. Design or download any of the models from the above-mentioned websites and print them using a 3D printer. Thank you.